It is now possible to connect the appearances of guest stars in history with the occurrences of explosive ends of stars within our own galaxy. These would glow briefly, with brightness large enough to have been recorded by the unaided eyes. The last such event to have taken place in the visible part of our own galaxy was in 1604 AD, just before the invention of the telescope, and was observed and recorded by Kepler. The next major step in the unfolding of this saga happened during the time sandwiched between the two world wars, when radar activity was at a peak. Carl Jansky, working at the Bell Telephone Laboratories, had constructed a steerable antenna to study the radio interference being observed in radar communication. One component of this interference turned out to be cosmic radio emission from the direction of the center of the galaxy. This was the beginning of radio astronomy. Many new types of objects started being discovered following the opening of this new window to the universe. Celestial objects emitting radio waves are currently studied using radio telescopes like the large single dish, one at Arecibo, Puerto Rico, or using an array of antennae like the giant meter wave radio telescope at Narayangao near Pune in Maharashtra. Moving forward a little more than 3 decades since the beginning of radio astronomy, we come to the Mullard Radio Astronomy Observatory of the Cavendish Laboratory in England. Jocelyn Bell, a research student, was observing radio data to study interplanetary scintillations, something akin to the atmospheric twinkling of starlight. Here, radio data twinkles when it passes through an interstellar cloud of plasma. While engaged in this, she noticed some unusual-looking data from a given region in the sky that was recorded on a chart on the evening of August 6, 1967. She labeled this as a little bit of scruff. The scruff reappeared in the same region of the sky at about the same time the next night. This data turned out to be a series of regularly spaced radio pulsars, separated by about 1.337,301,1512 seconds. No known celestial source ever showed regular periodicity on such rapid timescales. It was also unprecedented that one could quote the period to an accuracy of 10 decimal places. What was the source of these highly regular radio pulses? There was some thought then as to whether extraterrestrials, jokingly labeled little green men, were behind these signals. It was deduced very soon that these were natural signals from a galactic radio source termed a pulsar. Rotation was deduced to be the underlying cause of the pulses that we observe from these objects. The interiors of a star that are only a little more massive than the Sun is compressed into a ball of about 10 kilometer radius. This is essentially a 10-kilometer radius ball packed to nuclear densities with neutrons. We know that the source is very compact from the fact that the pulses are of such short duration. In this compactification process, it starts to rotate extremely rapidly, once every second or even faster. It also gains an enormous magnetic field, some million times the magnetic field strength of Earth. These gigantic magnetic fields pinned to the pulsar and rotating at such enormous speeds act like a giant generator, producing enormous electric fields. Charged particles accelerated to relativistic speeds in these huge fields produce the radio radiation that we see. But why pulses? This would mean that the site of radiation is localized on a small region on the surface of these stars. As the star rotates, this localized region and the emission from it becomes momentarily visible and then moves out of sight. The star acts as a cosmic lighthouse, sending out beams of radiation into the interstellar space. If we on Earth happen to intercept the beams from any of these objects, we will detect a radio pulsar in that direction.